Thank you, Michael. Thank you, everyone, for joining. I really appreciate you taking the time to spend a little bit this morning with Honeywell and to learn some more about the Swift wireless fire technology. This presentation is intended to help walk you through an introduction to Honeywell's wireless fire system so that you can feel more comfortable working with it, offering it to customers, and helping with any installation issues that may come up. So we'll just jump right into it. The agenda today will be a swift introduction. We will try to answer a few basic questions, like what is Swift and how does it work? Which products are included in the Swift system? Where will Swift make an impact? And who would benefit from Swift? We'll end with noting where you can go to learn more and how to follow up with us for some technical support. We'll also do a live demonstration as we get through some of the issues that I'd like to present today so that you have a sense for how Swift works when you're there in the field. Finally, we'll end with a Q&A session where you can ask any questions and I'll do my best to answer them. So first, what is Swift? Swift is smart, wireless, integrated fire technology. It's a Class A commercial wireless fire system which uses a robust self-healing mesh technology for a stronger, more reliable network. Swift now includes wireless AV bases that enable the wired AV you already use to be integrated into the Swift mesh. Swift devices function just like their wired counterparts while providing installation flexibility in a wireless format. So we talked about Swift being a wireless fire system with a Class A mesh, but what does that mean in a wireless sense? Everyone knows what Class A is for a wired fire system, but for wireless, what that means is that each wireless device has two paths back to the gateway. You see on the right there an image of the Swift wireless system connected to the fire alarm control panel. And so the Class A notification means that each device wirelessly locates and begins communication with at least two parents. This is so that if any one parent is to be disabled or removed from the network, that device still has a path back to the gateway, which is on the wired SLC and can therefore communicate with the fire alarm control panel. I mentioned Swift can be integrated both as a standalone wireless system or integrated into a wired environment as an extension of a wired fire alarm system. The components of Swift we'll go through in a few minutes, but I want to highlight first the WUSB and Swift Tools, which is the free user interface program that Firelight provides to communicate with the Swift mesh network. These tools will help you to navigate any challenges, to moderate the mesh network as it goes through its formation, and to do any diagnostic work that needs to be done post-commissioning. So let's talk a little bit about system specifications and what Swift is. Swift is up to 4 gateways per installation. One of the common questions I get is around adding extra panels, and we'll talk about that in a minute, but adding extra panels does not add extra capacity because 4 gateways occupy a singular RF space. And on those 4 gateways, each gateway can manage up to 49 devices. So 49 devices plus a gateway constitutes one mesh. So in total, in any one installation or any one RF space, there is a system total of 196 devices plus 4 gateways. For some legacy Firelight installations, a display driver may need to be added to the mesh in order to properly communicate troubles to a panel that is not wireless enabled. That's specifically the MS9600 or MS9200 UDLS on legacy installations. Now, all 4 meshes can overlap continuously. This means you do not need to physically space out your wireless fire system to segregate one mesh from the other. They can be completely overlapped without any self-interference. The system will manage the devices so that their communication runs uninterrupted and is able to transmit each of the signals from standard I'm alive, I'm functioning signals to mesh formation or in rescue mode if any device or part of the device is disabled. It's critical that a site survey be conducted so that we can understand exactly what the connection strength will be, and we'll go through the site survey requirements in coming slides. Now the system specifications we'll go through in a little bit of detail. Swift operates within the ISM band of 902 to 928 megahertz. Swift operates in a frequency hopping and spread spectrum format, meaning that the system has been designed to be robust and able to manage local interference sources without interruption to the network. Swift operates on a 50 milliwatt transmitter utilizing 17 dBm and operates through a cascading wave communication protocol. It's a Honeywell patented and designed system that is, again, designed to be immune to interference sources that are providing ambient noise in the space, as long as they're operating in a method that the system can manage. There are multiple antennas in each device to overcome orientation issues, so there's no need to aim any device at another device to obtain an optimum signal. One of the questions that you or your customers will have is about range. This can be for a number of reasons, whether you're trying to apply a wireless system to upgrade a sprinkler building, or whether you're trying to do a full wireless system or extend it on. And the best answer on range is unfortunately that it depends, because it always depends on exactly what the wireless system is trying to communicate through, just purely based on the physics of the radio technology and the medium through which the communication signals are trying to transmit. So it works best in low metal environments or environments kind of common to any office building infrastructure. So it can communicate through cement or through sheetrock or through drywall especially. But a row of metal file cabinets or metal lined walls for some reason, or low E glass can prevent communication challenges that can decrease the communication strength in the same physical distance. So Honeywell recommends a site survey, and we'll talk about the site survey and what's needed for that on the next slide. But this all dictates what the range can be. Now, a normal fire operating layout where you're utilizing detectors and AV devices or monitor modules at a normal clip can easily be accommodated by the Swift system. There is a primary connection minimum signal strength threshold, which is -55 dB at installation, and this ensures immunity at a 3-foot distance to a 1-watt interference source. A final note I want to call out is that metal backboxes, if you're in a retrofit environment, should not be used. A metal backbox can diminish the signal output and create a local Faraday cage around any device and disrupt the device's capability to communicate with the rest of the mesh. So please ensure you're utilizing a plastic backbox when installing wireless devices. Swift Tools. Swift Tools, as I mentioned, is the user interface program that is free for download on Firelight or silentnight.com, and it offers end-to-end control of Swift. Through Swift Tools, you can generate site survey reports ahead of installation. You can manually operate mesh creation and formation, and you can download diagnostic detail. All these things can help you to create documentation at commissioning so that you have a record of the proper operation of the system before handing it off. Swift Tools routes through the WUSB, which is pictured at the bottom of the slide, and is the way that your laptop is able to communicate with the wireless mesh. So the WUSB, although it plugs into the USB port, is not a storage device, it's actually an antenna. Swift Tools runs on Windows XP 7, 8, and 10. Like I said, it's available free for download, and it really is a great resource. Swift, however, was designed to be able to be installed manually without Swift tools, but you will not be able to take advantage of the full suite of features that Swift is able to deliver without using Swift tools. So a site survey, I've mentioned this a few times now. Finally, we'll go through it to get you a little bit of an understanding of what the purpose of a site survey is. And this is what the live demonstration at the end of the webinar will focus on. So the site survey consists of two parts, a link test and an RF scan. So these are two parts that test the site connectivity. I mentioned range earlier. The reason for the site survey is so that you estimate the range, or replicate the range that you will be using in real life and using no special tools. So the site survey, specifically the link test, is predicated on just using actual devices. So I normally use a smoke detector, but you can use anything that you're going to be using in the actual site to conduct a site survey and confirm site feasibility. It's a device-to-device test that generates a signal, a specific signal, where you dictate which two devices will connect and can measure the signal strength between those two devices. This allows you to test any of the medium available on site. So if you've got some inner office walls that are just drywall, you can test that and confirm that you can go through 2 or 3 sets of walls with no issues. Or if you have cement with rebar inside of it, you can test that connection to make sure that that will present no issues if you're going one floor to another floor on one mesh. And so we really recommend that you take a handful of devices. I always recommend taking a total of 6 devices so that you can take 4 devices and do the link test portion with 4 devices in sequence, because Swift will allow you to take those 4 devices and connect device 1 to device 2 to device 3 and device 4 and so forth. And you can therefore in series test a sequential layout of rooms. So you can test one type of connection and another type of connection, and a third type of connection, and so on, all at the same time, and measure and record those results and download them through the site survey reporting feature into a report that you can save. The second part of the site survey is the RF scan. Now the RF scan is a radio frequency scan. It is going through the different radio channels in the local RF area, and it is scanning those channels for existing sources of transmission, what would normally constitute interference. And so what it's doing is it's spending 2 minutes on each channel looking for anything in the area that's transmitting, and it is going to record the interference or the occupancy of any one channel. And again, that information will be available for download through Swift Tools site survey reporting feature. So those two things combined, the link test of any 2 devices, and this link test is repeatable. So if you just have 2 devices, you can run a link test over and over, recording the results each time, and combining that with the RF scan to demonstrate or confirm the availability of each channel in the 902 to 928 ISM band will generate a good picture of if the site that is looking to employ Swift is a feasible site. Now there is a local report out feature, so the link test and the RF scan will both deliver a series of blinks in the LED pipe that will allow you to rapidly tell if it's a good connection or a poor connection. There on the right, you can see the link test results. And this is coming from a quick start guide that you can download off of Firelight or silentnight.com. But it'll give you a quick report out on exactly how the test went, even before you go to Swift Tools. So it's a good visual indicator of a successful or an unsuccessful link test or RF scan. The reason I recommend taking 6 devices is you can spend those 4 devices on the link test, but then you spend the other 2 devices doing the RF scan, because the RF scan will take 70 minutes, 70. And that's because it's doing 2 minutes on each channel and then a little bit of report generation, so they can report that out. So I mentioned before being able to do a site survey report through Swift Tools. That's a printable report that you can download from Swift Tools, where Swift Tools actually retrieves the information from the devices that were used in the site survey. And again, these are not special devices. This is a smoke detector or a heat detector or a monitor module or an AV base, whatever device you have on hand or you're going to use in the job. Those are the devices that can conduct a site survey and download that information into Swift Tools. You can see on the screen a few screenshots which kind of represent the type of data that you'll retrieve from the devices during the Swift Tools site survey reporting feature. And we'll go through this in a live demonstration a little later in the webinar. You can use these site survey reports to demonstrate to the fire marshal the occupancy of the channels and the good connections that you developed as you develop your commissioning report, especially because some fire marshals or AHJs may not be as comfortable with the wireless system as they are with the wired systems they've had for years. So I'll go through the Firelight portfolio because I want to give a sense of which devices are included in Swift. So first there's the gateway. The SKU is W-Gate, and the gateway, it's like we talked about. The gateway manages the mesh, and the gateway controls the other devices and arranges their communication patterns so that they're able to deliver a good, robust communication pathway. We have photoelectric smoke detectors. So there is a smoke and there is a photothermal, the SD355T, and there's a heat, the rate of rise in the fixed version. And these are both based off of legacy styling. So these are the legacy styling 355 series detectors. And they should be very familiar to you as they operate with all the same settings, all the same hardware interface as the wired versions. It's a similar story for the monitor module and the control and relay modules, developed and based on the wired versions. So again, very similar operation compared to the Firelight wired versions. The USB, like we talked about, is the USB dongle that plugs into your laptop and allows Swift Tools to interact with the wireless system. Now, I mentioned this before, but I'll repeat it again because it's important. Any retrofit utilizing Swift on a legacy fire alarm panel, and it has to be an MS9600 or an MS9200 fire alarm control panel, these legacy panels are not wireless enabled. So to properly display the troubles from the wireless network, there will need to be a wireless display driver for each mesh. And for each display driver, there needs to be an annunciator. And so these are the devices here at the top right, a wireless display driver and an annunciator. The wireless display driver is part of the mesh, and it communicates via data bus to the annunciator, and the annunciator will share the specific trouble because the older legacy panels will only be able to display some very generic trouble saying, wireless trouble this device. Now in 2019, we launched a new wave of products for Swift to fill out the portfolio. These are the AV bases, the red and white ceiling AV bases, which can accommodate system sensors, L-series notification devices, and the pull stations, which have the same look and feel as the wired pull stations in English and Spanish. A synchronization module, which we'll spend some time on in a few slides, but it really enables you to hybridize an existing wired notification system with a wireless notification system so you can have wired and wireless AV devices operating in sync. And then the wall AV bases in white and red. So these AV bases for ceiling and wall are now available, and they can integrate the wired L-series system sensor AV devices into a wireless system. And this actually offers addressability for a notification device for the L-series system sensor devices, which we previously were not able to offer. I'll briefly touch on Silent Night. It's all the same devices, just in the Silent Night branding. And the one key point, the reason I brought this up is to say Silent Night panels have to operate Silent Night devices for panel protocol reasons, and Firelight panels have to operate Firelight devices again, for panel protocol reasons, so that the devices can properly communicate with the fire alarm control panel. So, spend a little bit more time on installation tips. The gateway, like I talked about, it works kind of like a modem in your house. It bridges communication from wired to wireless. It is powered by the SLC, or, and this is our recommendation, it can be powered by an external 24-volt power supply. Each mesh requires one gateway. So it's important to calculate one gateway using one SLC module address for each mesh. So it could be a total of 4 if you have that many devices required for your wireless system. For legacy panels, calculate 3 SLC module addresses for any one gateway because of the way we've had to break up the troubles to communicate with the non-wireless enabled legacy panels. Monitor and relay modules, as I mentioned, do not use the metal back boxes because they will block the signal. These are best used with the SMB 500 back boxes. And again, they're used to monitor, just like their wired counterparts, any open contacts, like a conventional pull station or a conventional water flow device, or it can control and relay. The module can do the same, can activate wirelessly a conventional device. The detectors, again, same look and feel as the wired version. And I hadn't mentioned this yet, but all the wireless devices are battery powered. They all use 4 of the CR123A lithium 3-volt batteries. These are batteries common to security systems or cameras, and they can be purchased at ADI, of course, or any retailer. And the Firelight detectors, they come with the 4-inch base included. So the 4-inch base that the detector mounts onto is included for Firelight and Silent Night brands. The display driver I talked about, only required for legacy panels. Each mesh does require one display driver. It is powered by 24-volt power supply and does communicate with the annunciator and does display the wireless specific events only. The annunciator, as I mentioned, connected via Swift data bus to the display driver, can be installed up to 6,000 feet from the display driver if you need to have more of a remote annunciator. Although, of course, the data bus requires wiring to be connected. And it does display the wireless specific trouble events for one mesh only. So it is required one of these annunciators and one display driver for each mesh if you're using a legacy panel. So pull stations, some of the more exciting features, the exact same look and feel, and in fact, they use the same key as a wired pull station. So a Firelight wired pull station will use the same key as a Firelight wireless Swift pull station. They do use 4 of the CR123A batteries. I should have mentioned this before. All the radio batteries on all the Swift devices are UL listed for 2 years of battery life. The pull stations are available in English and Spanish. The Spanish version has the LX suffix, or excuse me, has the SP suffix. The LX is the English version. And it has an integrated LED to display status. And it does actually, this is a new feature for the pull stations and AV bases. It's able to accommodate this battery cartridge. The SKU is W-BATCART, and it operates like a 4-battery quick change cartridge. So you're able to change all 4 batteries at once. The pull stations occupy 1 module address and 1 wireless point. We'll go through a summary of module addresses, detector addresses, and wireless points on the slide later on. But it's important when sizing your panel to keep track of how many module addresses you require because not every device is just 1. And we'll talk about which ones are not right now with the AV bases. The AV bases are available in 4 models. There's red and white ceiling and red and white wall. They use the L series notification appliances from System Sensor, the horns, horn strobes, chimes, and chime strobes. I've written in strobes here twice, but they're able to accommodate all these devices, plus the new low frequency sounders and sounder strobes. The AV devices, because of their activation of a notification appliance, actually require an additional 4 of the CR123A batteries. So each AV base ships with 8 of the CR123A 3-volt lithium batteries, 4 for the radio, which will be 2 years of operation, and 4 for the actual notification appliance itself, with a lifetime determined by the settings and the requirements of that notification device. So a chime only is going to operate much longer than a low frequency sound or strobe at full settings. So the sound setting, which temporal is set on, these things are going to have an impact on the battery life. And these different battery life estimates are all on the data sheets. The data sheets and the manuals for the AV bases will have a breakdown of the exact battery life estimate by device type, by notification appliance type. And I mentioned earlier about estimating and sizing your panels correctly. These AV bases occupy 2 of the module addresses, but only 1 of your 49 wireless points. So I'll say that again. If you're sizing a panel, you're going to have to allocate 2 SLC module addresses for each one AV base, but it only occupies 1 of the 49 wireless devices in your mesh. And the reason for that is because of the AV notification appliance, which is generating separate troubles for the L series notification appliance and some different troubles for the AV base to the fire alarm control pin. So the sync module, it provides a wireless interface to a wired NAC solution. It outputs a master synchronization signal, and it can synchronize AV devices or monitoring inputs or control inputs. But basically what it's doing is it's making the master of the wireless. So the wireless side will be the master, and the sync module will push that synchronization signal into the wireless side to make, to the wired side, to make the wired side slave to the wireless side, and to enable that synchronization between wireless and wired AV. And this sync module, it is only required in situations where there is wired AV and wireless AV, and they're in the same visual space, so they need to be synchronized. The synchronization module is powered by 24 volts. It does have 4 backup batteries, and that's to enable the continuous communication between both the wired side and the wireless side in case of power drop. It can be used to activate multiple points or zones. I mentioned earlier, in fact, the only addressable AV that we offer right now is through Swift. That's through the AV base. And if you do currently have addressing, the synchronization module will be a good way to take that and support that addressing in the hybridization model. Another positive feature of the sync module is that it's able to support legacy system sensor devices. So it can push that synchronization signal from the wireless side into not just wired L series, but also wired system sensor Spectraler or Spectraler advanced devices. So if you have a legacy installation and you're updating only part of it, and you need to maintain that synchronicity in the similar or singular visual space, the sync module can enable you to do that without replacing the existing AV devices. The sync module also occupies 2 module addresses, but 1 wireless point, similar to the AV base. So this is the overview I mentioned. The gateway requires 1 module address and 1 wireless point, except in the case of a legacy MS9200 or MS9600 legacy panel. Detectors require 1 detector address each. Monitor and relay modules require 1 module address each. Pull stations, 1 module address. And the sync modules and the AV bases require 2 module addresses each. So be careful of this when you're sizing your panel. So where is Swift best suited to make an impact? Well, there are 4 key situations where Swift has a distinct advantage over wired systems. First, where it isn't feasible or desirable to pull wire or conduit. This can be due to a historic structure or an artistic design, or if there is a health hazard like asbestos that is isolated and isn't feasible to remove or penetrate. Swift can be best suited to make an impact when time is a key component of the project. Swift can help reduce time on site by offering a predictable installation schedule, avoiding surprises in the walls that may prevent pulling wire. Or if the installer's time on site is reduced due to outside scheduling issues, Swift can replace the wired system because the overall installation time is lower, allowing installers to get on to the next job quicker and meet tighter timelines. Swift can be ideal when there is a wired system in place, but changing needs mean the existing system needs to be expanded or updated. Adding a gateway and a few detectors or AV devices is a quick and easy way to expand or upgrade a system without cutting holes in the walls. And finally, when the structures are under construction and wired systems aren't feasible, or there's a temporary structure that needs fire protection but can't be permanently wired in. A common example of this can be trailers behind the school when a district grows beyond the capacity of its existing buildings, but it hasn't had time or funding to build the new buildings yet. Swift can also help avoid costly fire watch services in historic districts if construction could potentially damage neighboring historic buildings. So there's a range of installation applications, especially right now with everything going on. The COVID-19 has really brought about Swift's capability in temporary medical facilities where they're rapidly setting up a COVID hospital and they need to increase new beds. And even if the site, generally these things will be in large outdoor areas or like a indoor convention center type of situation where the convention center itself already has sufficient fire alarm installation in place, but a fire marshal would like to have more due to the increase or the changing needs of the system, adding the extra beds and having more people on site more permanently can be a good opportunity to deploy a wireless system in the short turnaround time period required by these facilities. So some of the listings that we have, we do of course have the UL listings, UL-864 for the system, UL-268 for the detectors, factory mutual, and one of the questions we get, of course, California State Fire Marshal and Fire Department of New York. We have both the California and New York listings as required. And these are the third-party listings which demonstrate the high quality to which all of your Firelight and Silent Night products are manufactured. So I've gone through a lot of the information so far. I want to direct you towards some great points to download more information. The Quick Start guides, which can walk you through the site surveys, and they break down the link test portion, the RF scan portion, and then your first mesh generation, your first mesh formation. So there's an installation quick start guide as well. I highly recommend reading the instruction manual, specifically the gateway instruction manual, because the gateway instruction manual manages all of the sort of the master instruction manual for the Swift system. The engineering specifications, drawings, data sheets, and other tools are all located on firelightandsilentnight.com. And then, of course, you can reach out to the tech support team that you utilize for your normal Firelight support requirements. And then I do specifically want to point to the regional sales manager map. So if you are new or maybe your region has had a change in sales manager recently, this is the latest that we have. So Honeywell has a number of support options in each region, broken down, as you can see on the screen now, with someone close to you, no matter which part of the country you're in. So I'm going to go in briefly into a live demonstration of pulling down the information into Swift Tools. So I'll go through that, and then I'll try to go through that in a few minutes, show you how that works. And then we'll pause and do a Q&A. I want to introduce someone from ADS Systems Group as well. So we'll do this live walkthrough now, and then we'll go through the Q&A. So this is this is Swift Tools. And the reason it's got a little bit of white around the area is because Swift Tools is meant for laptops, and I have an external monitor. So I'm going to leave it like this just to demonstrate the way that it's critical to have proper resolution on your screen. This is one of the first time issues you can have on Swift Tools is if your resolution settings have changed on your laptop, the display may be incorrect, and so it's important to have a good or the standard, the default resolution setting before you enter into Swift Tools. So just real briefly, you open the existing job site, and it's going to pull forward all the different job sites I've worked on. So I'll open my office. And so from here, you're straight into the site survey, create mesh network, or diagnostics options. So you would choose site survey. And so because I've gone into an existing job site, it's going to remember some of the devices that I've used in previous data. So when you've done your site survey, as long as the devices stay in their base, they are maintaining the data, right? So you've done your link test, you've done your information, and the devices are storing that data. And they'll continue to store it once you tamper it, because they need to be tampered to communicate with Swift Tools. So I'm going to go ahead and remove some of these devices. And I'm going to go ahead and tamper. So what I've done is I went ahead and ran an RF scan ahead of this call, so I can show you how to download the RF scan results, and then I'll briefly do a site survey so that you can see how quick it works. So I've tampered device 121, a heat detector, and I've tampered device 122, which you can now see here in the communicator pane. And so I'm going to select these devices. It's taking a second to load here. In fact, I'm going to go ahead and close it out and then restart, just because it seems hung up on what it's found. So we're going to go ahead and do that. Okay, and we'll go ahead and start then. And so the USB will scan the available area, and it will find the existing devices in the area. And so it should populate. So this is the way it should work, where it should populate the field with the new devices. And so it does give you step-by-step instructions. So I've forgotten to retrieve. So when you have the field populated, go ahead and retrieve the data. And that's one of the benefits. It does give you kind of a step-by-step instructions here at the top of Swift Tools. And then if you do go out of order, it will prompt you to go correctly in order. So when you have the detectors out of their bases, ready to retrieve the data, like I've done. And once this data is retrieved, you can go ahead and click next. And it will show you which channels are available and which links are done. So this is the high-level result for my office. And this makes sense because I'm running some things. So we'll go through quickly what this is. This is a high-level result. It's showing one excellent link, and that's from device 122 to device 121 because each device looks for the sequential device below it when it forms this link. So each device 5 will look for device 4 will look for device 3, and so on. And the lowest number of 1 is always not going to form a connection because there is no device below it to form a connection to. And I can get a detailed result of these results. So I got a negative 37 dB, which is fantastic. It's an excellent connection. And this is the signal strength for a connection. I go back to the site survey. And then this is why it's saying the site is not recommended. And that's because of the detailed view of the RF scan. So the RF scan has found that there is potentially either interference or a lack of availability of these channels. And so the reason for that is because I cut off the RF scan early just to show how the demonstration would work. So what's happening is it's conducted a scan and it's shown no interference here of the channels 902 through, I don't know, 924 or so. But it was not able to scan these channels. And so it's interpreting its inability to scan these channels as occupancy. But that's because it didn't have time to complete the overall scan. But I just wanted to show this because it's more visually, it helps you to understand better when you see the different things it can do rather than just all good results all the time. So you can download, you can export this to Excel. Oh, the last thing is the detailed view of the background noise. So we'll show you the background noise. And this is what its failure to scan all available channels has demonstrated, is that because it's unable to scan those channels due to lack of time because I interrupted it, it interprets that as a failure. So it's important to allow all 70 minutes, 70 minutes for the RF scan. And then you can export those results to Excel. It will just ask you to do this. You give it a unique name, and you can save the results. And then you have a downloaded result set that you can. So now it's successfully saved, and you can open that at your leisure. So I'll quickly do a quick link test so that you can see it. And so I'm going to put the devices back into their bases. Doing so, that will reset the existing connection data. And so once the two devices are back in their bases, they'll blink amber for 20 seconds. And at the end of 20 seconds, they will give a visual indication of what the result is. So device, in this case, 122 will be looking for device 121. And after 20 seconds, they will find each other. And I will be able to show you the result. It is important to do them in order. And I fear I may have done them out of order. I did. So I did them out of order. But just 20 more seconds and it will show you the result. So right now, device 122 is scanning for device 121. And again, you can delete the last results of your last test just by putting it into the base, securing it, and that will start a new link test. The other thing I hadn't mentioned is to trigger link test mode, you put one battery in the first slot. This is the way the device knows it's currently in link test mode, and it will first look for the nearby devices, and then it will second go into RF scan mode if it has been coded between 101 to 159. So now the link test is complete, and go back in here, and I will allow, well, I have to go ahead and tamper the devices again so that they're able to communicate with the USB. Have the devices in range of the USB, and then they will show up in the communicator pane again, and then we'll be able to download the devices just like we did last time. So we'll go ahead and retrieve the information. And because of the same devices we'd already done, we need to retrieve the information again. We are retrieving the information. And then once done, we'll be able to look at the link test results from the most recent link test. So this is still showing the old RF scan information because I hadn't done it, but it is showing the new link test, which I just did. So that's it for the site survey. It's as quick as that, and then you would just download the new Excel file to your laptop, and you would give it a new name so that you can differentiate from your previous test. So that is how Swift Tools works. I'll go back to the PowerPoint. All right, and so I'm going to pause here. I'm going to go into the Q&A in a few minutes, but first I want to take a few minutes to introduce AJ Shaw, who leads ADI Systems Group out of Louisville, Kentucky. AJ, are you still on?
I am. Thank you very much, James. Appreciate that. I'd like to thank everyone for joining our webinar today. Also like to thank James again for taking time out of his day to inform everybody, and hopefully he's answering some questions for everybody. If not, please, at the bottom of your screen, if you just move your mouse a little bit, you'll see a Q&A section. If you want to just type some things in there after I get done here, that will pop up on the screen. James will be able to answer some of those questions for you. I'd also like to thank Mike Maston. Sorry, got a little confused here. I'd like to thank Mike Maston for putting these webinars together for us and for you guys and all of our vendor partners and customer partners. Again, I'm AJ Shaw from the ADI Systems Group in Louisville, Kentucky. I manage a team of reps here specialized in fire intrusion and home automation. We also have a group of experts out in California. For any of the West Coast people, they're open till 5 o'clock local time out there. For more than 25 years, ADI Systems Design has provided our customers with recommendations and best practice knowledge to ensure successful system integration. Our team of experts is here to help all of our system integrators' needs from, as I mentioned, 8 a.m. Eastern time to 8 p.m. Eastern, 5 o'clock Western, Monday through Friday. If you would like, give us a call or email us. We're happy to assist you with any of the Honeywell fire products, the Swift, Firelight, SilentNet, as mentioned in there earlier, that works with both those systems, and any of the huge selection of low voltage products that we offer. Our phone number and email information can be found on our website, or follow us at ADI Global on our Facebook page or LinkedIn page. And I think that's all I've got. So James, I will turn this back over to you for the Q&A section.
All right, thank you, AJ.
You're welcome. Thanks for doing this.
So Michael, do you want to read any questions? I see there are 9 available. I'm not sure how to look if I open the question pane.
I'll read you the question.
I can go ahead and take it on.
Etc. Joe Camarado from New Jersey wants to know, is there a New Jersey accredited course for Swift with respect to continuing education units?
Oh, that's a great question, Joe.
I'm sorry. If you don't know the answer, we'll get Daniel Briner in the middle of this.
Yeah, no, I was going to say, Swift is now, there is a unit of Swift within Firelight and Silent Night's training academies. I would definitely recommend to reach out to Daniel Briner to make the connection for the next available session. I don't have that in front of me. So there is not an independent Swift course, but it is, there is a Swift unit of the training academy for Firelight and Silent Night brands.
Okay. J.R. Francisco Guinto wants to know, do you have weatherproof Swift devices to offer or currently in production?
So that's another great question. Swift is designed to be used indoors. So Swift is designed to offer a fire system within a building, and it is not, in fact, designed to go building to building. So we can't recommend a weatherproof enclosure because that would, of course, indicate it is going outside. And probably the largest challenge for an installer with an outdoor application is the enhanced drain on battery life driven by outdoor weather, especially up here. I'm in Northford, Connecticut. It can get quite cold. Summers are obviously warm, and that will drain your battery significantly faster than the 2-year listed battery life. The product is designed and listed for use indoors only. And so no, there is not an outdoor box, although in future we're evaluating how to make that happen as we continue to invest in the Swift product line.
Thank you. Junior Francisco Guento followed up. Do you have YouTube video for live demo for site surveys?
So yes, we have. We absolutely have YouTube videos. There are videos sequentially listed on the Firelight website if you go to more resources, or they're on YouTube. I think you just have to search Swift or have to search Firelight Swift. And the systems architect and the engineers, there are some videos on there specifically about doing the site survey and how to implement your first mesh. So I highly recommend checking those things out, either through the Firelight website, the Silent Night website, or again through YouTube directly.
Okay, thank you for that answer. That was good. Samuel Escobedo wants to know, can we use speaker strobes?
Unfortunately, no. So speaker strobes require a significant amount of data to be transmitted to transmit the message the audible voice is reading. What am I trying to say? Speaking uses more data than does in a chirp or a horn or a chime. So we don't have the capacity within the current design to utilize speaker strobes. So no, unfortunately, only horns, chimes, and sounders, the low frequency sounders, and their strobe counterparts are available for wireless at this time.
Okay, I'm going to read this as it is written. I'm not sure if I'm going to get it right, so you may need to interpret. This
Okay.
came from Keith Rodenbaugh. When a device goes, do we need to reprogram device? Maybe that's replacing an existing one. Keith,
Yeah.
I'm going to restate that if we don't answer this properly.
Sure. Well, I'm going to interpret it the way you did, Michael, to say, if a device goes, meaning, I don't know, if it gets destroyed or if it dies or if it's bad out of box or well, not out of box, you wouldn't have put it in the mesh. But I guess the question is, if you have a device up and running, and then we'll just say it gets destroyed, right? A kid throws a baseball at it for whatever reason. You can take a new device and import it into the mesh. So the way the mesh is structured and to isolate each mesh from the other meshes is you assign a mesh ID or a profile to each mesh, and that's managed by the gateway. And so the gateway pushes out that profile into every device that's in the mesh. And so if you, for whatever reason, even if you're just expanding it, maybe nothing was destroyed, but anytime you need to import new devices into the mesh, you're going to take those new devices, you're going to have them near your Swift Tools laptop, and you're going to have them near your gateway or any device really in the mesh. And you're going to download the profile from an existing device, and you're going to upload that profile into your new device, and thereby you're going to import that new device into the existing mesh. So it's a little bit of programming work. It's just a download upload process. It is mapped out in the manual, the gateway manual, if you take a look at that. But yes, absolutely possible to add new devices into an existing mesh.
Okay, Alexander Plasko would like to know, are there gateway wiring diagrams?
Yes. So each gateway is wired via a diagram that is on its manual, and I believe it's on the data sheet as well. But absolutely in the manual, it shows you how to wire it either with 24-volt power or SLC power. And there's some different options, but yes, the diagrams are absolutely in the manuals.
Thank you. Samuel Escobedo asked the next two questions. The first one is, will it let us know if batteries are low?
Yes. So per UL requirements for low power radios, which is what Swift qualifies as, Well, two things. Per UL, we will give you at least 7 days. So 7 days before the batteries die, you will get a latching trouble at the panel. But you will get, before that, low trouble battery alerts, non-latching troubles at the panel as well. So, and then within Swift Tools, you can go and check on the status of any battery at any time by looking at the individual device. And in that communicator pane we saw on the right where you could see any device, it can actually tell you the status of all 4 batteries at once. So yes, absolutely, it will give you notice of low battery.
Okay, the second question he asked, are the dip switches for setting up the addresses on the devices?
Yes, so it's the exact same code wheels that we have had, my understanding, for a very long time on Honeywell fire equipment. So the Firelight code wheels you're used to, they're still there on the wireless. You just use a flathead screwdriver and code them in.
Perfect. An anonymous attendee says, what is Swift fire alarm control panel model for new install? So I guess he's looking for the model number and then where he would find the cut sheet as well.
So the panels for Swift, there actually are no specific panels for Swift. There are the new Endurance series for Firelight, so the ES50 and ES200 are wireless enabled. Maybe that's because I had mentioned that the legacy stuff is not wireless enabled. So the MS9600 and MS9200 panels can support Swift, but you need extra devices to make it work, the display driver and annunciator for each mesh. But the ES50, ES200, ES200X, the Endurance series, those do not need special equipment to work with Swift. And then every Silent Night panel works with Swift as well. So 6820, all the Silent Night panels work with Swift.
Okay, Keith Jones says, I programmed an ES200 with Swift and cannot clear the extra points. I am also not using a display driver and an annunciator will still work. I guess the second part was a statement. The first part was a bit of a question. I programmed the ES200 with Swift and cannot clear the extra points.
Yeah, I would recommend you call into our tech support with that. My initial feedback is the ES200 in theory it shouldn't need an annunciator or display driver. If you have an annunciator for remote annunciation purposes, you would use a display driver. I guess I'm not totally clear what the extra points are, but I would highly recommend you call into our Firelight team. I know especially Eslava is well-versed, or Rhett Perkins are both well-versed with the Swift material. And if they can't help you, then they'll escalate you to me, and we'll take a look at it and get you with the engineers, and we'll figure out what's going on. But things to look at is to make sure you've got 2 points available for your AV bases, make sure your settings are done correctly per the manual in terms of type code. Yeah, there's a lot of variables it could be, so definitely call into tech support.
Okay, Samuel Escobedo asks, can we use antennas to extend signals?
So the way Swift works is that each device is a repeater. So I'll give you an example. If you're in a warehouse that's sprinklered and you need a pull station on one side, and then it's literally half a mile before the next pull station you need. What we would recommend in that case is that you use, any device can work, but we would probably recommend a monitor module or a relay module just to use those devices as repeaters. And then you can go a further distance with those extra devices acting as repeaters than the individual device to device connection range would allow. So if you do your site survey and you're not getting good enough signal, try to make the mesh more dense by adding extra devices to function as repeaters, and place those in between the devices that you need to connect, and Swift that way can extend the range out.
Okay. Ishmael Quiones wants to know info for Puerto Rico. I'll take that one because I actually know the answer, if that's okay.
Go for it.
Ishmael, if you know, I'm sorry if I'm not saying your first name properly. If you know Orlando Mercado, that's the best place I can get you started. If you don't, please send me an email and I will join you with his V card. And I'm Mike.Maston, Masten, at adiglobal.com. So that was that answered. Gary
Thanks, Mike.
Livio wants to know, when replacing defective devices like number 2, do we replace/add the new device to the same address or assign a new device number?
Yeah, if you've got a device that's defective, I guess you can absolutely replace. So if you've got module address 2, right? Say, I'm just making this up. Say it's a pull station and your pull station's bad. You buy a new pull station, you pop down the ADI, you pick the pull station, you put it in your mesh network. You can absolutely swap out one for one. You would, like I talked about before, you would import that device into the mesh. You would use the code wheels to set it to the code that you want, and then you would auto program your panel to go and find it. And you can have the device be the address that you want it to be. Swift doesn't care about your module or detector addresses, other than to the extent that like the AV bases need 2 sequential module addresses to be allocated to them. So if it's an AV base and you make it number 2, you need to leave number 3 free so that the system can properly transmit troubles. I hope that answers the question.
Okay, Steve Moore has asked the last 2 questions. The first one is, can you program Swift over telco lines remotely?
No. So one of the features that we were very specific in making for Swift is it is a closed system. So the gateways are locked. They require a password and a magnet to unlock the gateway to add or delete devices or to form or collapse the mesh. So if you have a remote interface program, you or facility manager, you cannot manipulate the Swift system. It will function with the panel the way that you could work with your panel, but you cannot remotely interface with Swift any more than you could with any wired device.
Okay. Steve also asked, why are plastic boxes so expensive, or is it due to low sales volume?
Yeah, well, frankly, yes, it is due to specific application and, getting the boxes up and running. If you look at IHS, the wired application is still, 95 or 97% of installations today. But we believe that as things go forward with Swift, there will be more wireless installations. And hopefully, these parts that are, run-of-the-mill parts for a wired installation will become the same for wireless. So plastic could go down due to volume, but that's exactly it. Is the volume isn't there yet, and so all of the Swift equipment is a little bit more expensive than its wired counterpart.